Alrighty, STEM Chemers. So here's the quick overview of what we went through in class with our new content, digging into properties of matter. So we worked on making a dichotomous key. That's this image here. You guys worked in your groups on this, but I did want you to get this in your own notes for sure. So I believe this was everything we wrote down in class, at least for the most part. So go ahead and get this into your own notebook as well. Recognizing that matter can be divided into either pure substances, right? It's all the same, all throughout, all the same, 100%, or a mixture, two or more pure substances mixed together, right? Not chemically bonded, just physically mixed together, right? We talked about how a mixture can be physically separated to become those separate pure substances, but a pure substance, you cannot physically disrupt it and turn it into anything else. If you want to change a pure substance into something else, you have to get pretty rough with it. You got to use something chemical. Then we saw that for pure substances, we have elements and compounds, right? Elements is the stuff that everything is made of, off the periodic table. If you break something down smaller than the elements, then you just get into kind of basic parts and it loses any of its individual characteristics. So elements are one variety of pure substance, and the other variety is compounds. And compounds are when you have two or more different elements bonded together with a chemical bond. And again, these cannot be broken apart by physical means, right? If these are going to change into something else, you're going to be doing a chemical reaction there. And we'll talk more about the details of all of that in the days to come. On the other side, we have our mixtures, right? You can have two different kinds, a homogeneous mixture or a heterogeneous mixture. Remember those prefixes, homo and hetero, homo meaning the same, hetero meaning different. So when we have a heterogeneous mixture, it has different identifiable parts. So think chocolate chip cookie, trail mix, water with sand in it, muddy water, ice water, kind of, right? You have a mixture of phases, so that could work. On the homogeneous side, it seems the same. You might look at it and think that it's a pure substance because it looks the same throughout. But in reality, it's not. We were looking at somebody's Gatorade bottle in class and saw there's a ton of different ingredients. There's obviously a bunch of stuff in there, but it looks like one thing. So some examples we came up with: soap, chocolate, a snickerdoodle cookie, sugar water. That could be like our Gatorade, okay? So that's the dichotomous key part. How do we organize matter? It's just kind of a good underlying understanding to have. And then the other thing we looked at was the phases of matter, or the states of matter: solids, liquids, and gases. And we looked at, just used water as our example, and we could have solid water or ice, liquid water, or gaseous water or steam. And we saw that a solid is going to hold its shape, right? It's going to be packed closer together, usually. And we talked about movement a little bit. It's going to move a little more slowly. We're going to get into all of that more in the coming days as well. Liquid water we're seeing as spread farther apart. It does not hold its shape, right? It takes the shape of its container, and it would move, the particles would be moving a little faster than the solid. The gaseous particles are going to be totally spread out. They are going to fill their container in any way possible. They will spread out as much as they can. They're going to be moving the fastest, have the most energy, and again, we'll get into the details of that. And then... was that it? Yeah, so they're obviously farther apart. So that's really it, like just some basic review stuff. I hope you have a wonderful weekend, and I will see you next week.